GCSE Computer Science Syllabus Statement 1.3.3K. Describe how a range of sensors can be used to input data in a computer system. So, sensors are a type of input device, but they're a little bit different. What we need to know for the course is a bit different. We need to know more about sensors than any other input device. I think, because the input devices that we learned previously, such as the touch screens and the whiteboards and all that good stuff. Well, we just have to know the theory, the principles of operation of them. But here with sensors, we have to apply them into scenarios which we don't know what basically we don't know what we're going to get in the exam. They're going to give us a scenario. We have to describe how sensors can be used for that. Now, that'll be looked at in the next video, but this video will go through all of the 9 sensors that we need to know, and then we can learn about how they are used. And we'll also go through an exam question as well in the next video. So, sensors are devices which read or measure physical properties. So, these basically are sensors. These are the 9 sensors that we have to know. This is the temperature sensor. This is the moisture or humidity sensor. This is the light sensor. This is the infrared or motion sensor. This is the pressure sensor. This is the sound sensor. This is the gas sensor. This is the pH sensor. And this is the magnetic field sensor. So these are what we have to know. So we'll look into them now. So basically, physical data is what is known as analog. This means that it's constantly changing and doesn't have a discrete value. Analog data requires some way to interpret. For example, a mercury thermometer requires you to look at the height of the mercury. So temperature can therefore have an infinite number of values. As humans, we can read these values. We can look at a clock and say, oh hey, it's 12 o'clock. Or we can look at a thermometer and say, oh, it's 35 degrees. But computers can't simply look at a device and say, oh, it's 12 o'clock. The data needs to be in some sort of digital format, a format that the computer can understand. This is done by using an analog to digital converter, or ADC, as we're going to call it for now. This device converts physical analog values into discrete digital values. So we get the analog data here, the ADC, and the digital data. Now, we don't have to know how the ADC works. We just have to know that it plays a part in changing analog data into digital data. When computers or microprocessors are used to control devices, it is necessary to use a digital to analog converter, so a DAC. And these are used with an actuator, which is a type of electromechanical output device used to control something. So an actuator could be an actuator could be like a relay or motor or valve, and we'll learn about these in output devices, because an actuator is an output device, but just know that actuators are used in the process of a sensor system, really. Actuators may require a digital to analog converter to receive an electric current rather than a digital signal. So we need to think about when microprocessors can read digital values, actuators have to read analog values. So we have to convert digital values into analog values. Something like this. So let's look at the sensors and the application of the sensor. So temperature we'll start with. So temperature can be used to control a central heating system, and controlling and monitoring a chemical process, and controlling and monitoring the temperature in a greenhouse. Now, note the difference between controlling and monitoring. Now, controlling is when you control something. So the microprocessor has something to do with the control of devices, of actuators. Monitoring is a bit different. Monitoring is when the microprocessor can read values, but cannot do anything about, can't change anything. All it can do is monitor, and if something is out of place, it can output a warning message. So we'll look at that in the next video as well. Moisture/humidity, used for controlling or monitoring the moisture levels of the soil in a greenhouse, controlling or monitoring the humidity levels of the air in a greenhouse, monitoring the dampness in an industrial application. Light sensors can be used to control street lights, controlling or monitoring lights in a greenhouse, and controlling headlights in a car. It's important that you know about these applications, just in case the exam throws something at you. So, for example, if the exam says, oh hey, describe how a microprocessor and a humidity sensor can be used to, control the humidity levels of the air in the greenhouse, then you're going to have to know these applications so that, you can, you can just know what to do for the exam. Infrared or motion sensor, controlling the windscreen wipers in a car, monitoring intruders in a burglar alarm system, and controlling doors in a shopping mall. So when you walk into a shopping mall, ooh, the door's open. That's done by a motion sensor. Pressure sensor, monitoring intruders in a burglar alarm system, controlling a weighing system, and controlling and monitoring a gas pressure related process. Also, pressure sensors can be used to control doors in a shopping mall as well, as they'll sense your weight and then open the door. Sound sensors can, again, monitor intruders in a burglar alarm system and monitor the noise of liquid dripping from a pipe. And finally, last slide, gas sensor can monitor pollution in water or in the air, monitor the oxygen and carbon dioxide in a greenhouse, and monitor carbon dioxide leaks in a power station. pH sensors, controlling and monitoring the acidity or alkalinity of soil in a greenhouse, and monitoring pollution in water. And magnetic field, last one, controlling an application which involves magnetic field changes, and controlling an anti-lock braking system in cars. An application which involves magnetic field changes, well, that can include stuff like cell phones, or so take your mobile phone, for example, or tablets. You could have orientation. If you turn your phone around, the screen will also turn. So that's pretty much how these can be used.